Someone get a 15-minute time. I see 7:37 right now, so I can only go about 15 minutes on a, if I'm going to download this. But the topic is proofs about integers. Remember what an integer is. What's an integer? Real whole number? Okay, positive or negative? Yeah. Whole numbers tend to only be positive, or in zero. But then the opposite of the whole numbers are included there. So it could be positive or negative. No fraction part, no decimal part then. All right, very good. Let's get some of these properties reviewed here. The associative property. All right, gentlemen.
So strong.
Okay, it works for addition.
Sorry.
It's all right. Smile for the camera. All right. I got a lot of people asking, so we're recording the lecture. Oh, come on, Mrs. Jager, you can walk in front of them.
Oh, I'm up.
Okay. All right, if you have three integers that you want the associative property, associate, group, it doesn't matter which two you group together first. Okay, so the associative property, the commutative property. When you okay, so John, when you go from your house to here, driving in your truck, does the distance change from when you go from here back to your house? Take the same route? It does not change. So commute, on your commute, the distance from work to school, or from home to school, is the same as the distance from school to home. So that distance is still the same no matter which direction you're going. Okay, A plus B equals B plus A. A times B equals B times A. All right. Distributive property. Oh, Mrs. Jago, that's okay.
You sure?
Yeah.
We don't want to be that
Get
guy.
back to your...
Awesome flex class?
Yes. I have a feeling they shouldn't be alone too long in their room.
I've got a random good bunch in there.
Okay, that's good. A times B plus C equals, somebody tell me, what do you remember from the distributive property? Okay. And that's used every once in a while. Now the addition, ADD for addition property of equality. When you started solving algebra equations in Algebra 1, you were using this all the time. If A equals B, then A plus C equals B plus C. If you add the same integer to A and B, the equality still stands. And we have a multiplication property of equality. Just put equals in parentheses like that. Multiplication property of equality states the same thing. for the hypothesis, or the antecedent, remember that? If A equals B, then that C comes into play. A times C equals B times C. Multiplication property of equality. All right. This next one I'm really interested in introducing because I'm not sure we've talked about that as much as the ones previous. The closure property. Holds for different operations. If A is an integer, and B is an integer, then here's the closure property for addition. This is for addition. Is an integer plus an integer equal to an integer? Okay. Then A plus B is an integer. And so we say addition is closed in the set of integers. How about another? Is there another operation where it's closed? Subtraction. Ditto marks here. Is there another one? Multiplication, an integer times an integer. So multiplication is closed in the set of integers, under the set of integers. Division? No? Give me a counterexample then. A is a certain value, B is a certain value. Okay. A over B would equal 1/2, which is not an integer. That's a good counterexample. So we could say addition, subtraction, and multiplication are closed under integers. Means the result, if you're using integers in your addition, subtraction, multiplication, the result's going to be an integer. The answer is going to be an integer. Okay, I've gone about 8 minutes, it looks like. Any questions on closure, the closure property? Did you get all that, Carol?
Yeah.
Okay. Now, I want to talk about even integers. The way that we prove or demonstrate that we have an even integer. An integer is even what's if stand for? If and only if. An integer is even if and only if n equals 2k, 2 times k for some integer k. Okay. An integer is odd. Oops. If and only if n equals 2k plus 1. We need a plus 1 there for some integer k. using that definition, show that 270 is even. Using the definition we just had. $270 equals, what do I have to show? I have to show that our n, which is 270, equals 2 times k for some integer k. 2 times what? 270. Not 180. 135? Okay. So 270 equals 2 times 135. All right. Let's use the definition to show show 4,875 is odd. By definition. That means there has to be an integer that I can put in the parentheses there that would equal 4,875. What's half of 400? 4,000.
2,000.
What's half of 800? 2,400. 37 times 2 is 74, right? What'd you say, 2,437? Okay, that is our integer k. There is an integer out there that lets us do that. So that proves that. Okay? Let's see. I'm at 12 minutes. Let's do this one. So if t equals 6 times a plus 8 times b, t equals 6 times a plus 8 times b, where a and b are integers, let me write it this way. A, b belong to the set of integers. You ever see that E, is that a new symbol? Kind of the C that almost looks like an E with the line in it. Belongs to is what that means. If t equals 6a plus 8b, where a and b are integers, or belong to the set of integers, show that t is even. Show that t is even. I'm going to have to wrap this up.